Okay, streaming started. Good evening, folks, and welcome to the YouTube Model Builders Hangout for Tuesday, December 13th, 2016. Barry and Mike's Model Railroad Tech Show live hangout presentation. I'm your host, Barry Rosier of Barry's Bench. And with us we have Johnny Reb, and our guest tonight is Andy Crawford of the N&W. So tonight we'll be talking about the Arduino microcontrol system. But first, let's take a few seconds to discuss the YouTube Model Builders. YouTube Model Builders is your free online source for model railroad information. We have our online e-mag that we put out every couple months. We have the live presentation chats and hangouts that we do Tuesdays and Thursdays. And as it is this Saturday night, the YouTube Model Builders live show. And this will be the final show for the year of 2016. So this will also be the final tech show for this year. So we got all kinds of new exciting things coming forward to next year. So let's go live here now. Yep. So tonight we'll be, like I said, we'll be discussing the Arduino microcontrol system with our friend Andy Crawford. He's going to be talking to us about it tonight. So Andy, take it away, my friend.
And I know we've talked about it, and it's been kind of a conversation amongst people on here. A lot of people have been kind of daunted by the idea of, of a circuit board that comes bare. And that can scare a whole lot of people. By what I'd like to do is assuage you of the fears of it. And I've got a couple ways of doing that before we kind of do the deep dive. Show you that a bare circuit's just not that scary. And the biggest reason why is community. But and not just this community here with a few of us that are doing things with Arduino, but the community at large around Arduino, doing everything from doorbells, home automation, RC aircraft, et cetera, et cetera, et cetera. And the model railroad community. And that's why I want to get to a couple of the things. So let's talk about what an Arduino is first. So this is what's called a microcontroller. It's not exactly wrong to say that it's a microcomputer, but it's not exactly accurate either. A computer is a general purpose computing device. It can do math, it can play a video game, it can do all kinds of stuff. This is a processor. It's designed so that when something happens, something else happens in correlation, or when a time is hit, or when these two criteria have been satisfied. And I don't want to confuse you with the complexities of that, but just think that it's quite simple. It does things like control lights really well, and it's so well suited to controlling crossing flashers or building lighting, structure lighting, or accessory lighting on your layout, or servos. That's a big facet of the Arduino. And thanks to the Arduino is the board that when it came about, things like 3D printers came, or commodity 3D printers. It was happening in the commercial space for $500,000 plus, but being able to buy a 3D printer as a kit and assemble it for $300, $400, $500 or more and build one at home became available because of that board.
Exactly. Yeah, you're totally right, Andy.
So this is Arduino. It's made by an Italian company. This is an official one, and there is a little license on it so that you can see if it is legitimate or not. But there's also a lot of compatible ones. There's nothing wrong with buying the legitimate ones. They're a little more expensive. This one happens to be a legitimate one, and I use this one for my testing a lot of times. But then once I've tested it, I will try it on the generics, and I'm getting ready to show you how much cheaper they are for deployment if you have multiple. If all you needed it for was one, then buy the legitimate. They're $25, $28, something like that. However, and let's just talk about those things. So let's talk about what it is and where you can get it. This model that I'm showing you is, the Matrix.
There we go.
This model I'm showing you is an Arduino Uno. It is it's not the smallest, but it's the most basic starter model, USB, power if you run it standalone. I run mine directly connected to the computer all the time, but you don't have to. I'll explain the reason why I do that in a few minutes. But you can run it standalone, and you could power it off from the AC jack. This one has 14 digital input-output pins and a number of analog pins that you can use for some things like rheostat knobs or a dimmer switch, for lack of a better description. There's also these really small ones that are smaller than a stick of chewing gum that have a limited number of inputs, I think 8 or something. So these 14 digital pins that are on the Arduino Uno can be used to throw 14 different LED lights or flip a switch of some kind to actuate something on a layout. That's an interesting board for modeling. Also, the Mega. The Mega is real popular, and I have a few of these that I use for different projects. This one, on the other hand, has 54 digital input-output pins. So on the Uno, you can control 14 lights. With a Mega, you can control 54 LED lights.
Wow.
So think about how many signals around a junction you could control. Since we've been talking about, trackside signal systems, I think these are so well suited to that job. And maybe at the end of the show, we'll talk about some of the where to go from here stuff, where we can talk about how LCC and JMRI and CMRI use the Arduinos, or can use the Arduinos. These are the two boards. They're available from a bunch of places or direct. You can get them from SparkFun. You can get these kits that have different boards. You can get the
Leonardo one.
Yeah, Leonardo. My hillbilly's coming out occasionally. But the Uno Revision 3 is $25 officially. That's the official one. However, you can buy the sucker for $3.50 off of eBay with free shipping. $3 for 14 accessories of DCC capable control. Now,
if you load the right software on there, you can turn, even like say you take a Arduino Mini, there was software that was published online where you can turn it into a 17 function DCC decoder, basically.
Yeah, it works as an accessory decoder.
Yeah.
And that's a couple places to get them. I buy a lot of the generics off of eBay because they're just handy for that. However, the community stuff is what's so amazing. So here recently, I've been perusing this article too because it's good. This is the most recent release of MRH magazine, and we are not going to spend our time reading this magazine to you. But anybody interested in amateur electronics of any kind, especially for model railroading, should really take a look at the MRH mag. As a model railroader, everybody ought to be reading it anyway. But this month's MRH, and we talked about this Arduino show, gosh, I don't know, 6 or 8 months ago.
Yeah, we probably did because when we were talking over the summer what we were going to do.
Yeah, and they just started talking about, and they've been talking about these for a while on the MRH forum, but this is the latest MRH magazine has this, quite long article about this so that you can kind of read and reread how to use some of these parts. It also has a little bit more advanced stuff that I'd like to get into and talk a little bit about too, about using proto boards. And I'll get into this part, it stacks, what are called shields, in just a second. But anyway, so they do a bunch of stuff, how to hook LEDs to it. There's also a lot of YouTube videos on YouTube, obviously, for Arduinos in general, but also model railroad specific ones. There's one fella named Dave Bondar who has done some really good Arduino stuff on YouTube. So that's MRH magazine. And then
I think his website is, what is it, Model Railroad Electronics or something like that? Yeah, Dave Bodner.
Yes, it's something like that. I've got that handy. I just can't remember what that is.
Yeah, because I took a pickaxe clinic from him before.
Yeah, he's into a bunch of this stuff.
Now this is the guy here on MRH, Dr. Jeffrey Bunz. Or Bunza.
Yeah, man, he is slick.
Yeah, he's the one, that whole blog, SMA, Small Model Animation.
Yep.
He started that several years ago.
Oh,
And
yeah. And there's actually a few of these that have been ongoing for this one's from 2014, but I've read some of these that have went back a couple more years than this that have pages and pages and pages of what people have done with them, what they've hooked to them, and they've broke it down how to do it, what pin. And this is what I think is so valuable about the Arduino
yeah,
compared to other things. I really genuinely was fascinated with what I found about the pickaxe after you started talking about that in the community and I started researching it. I think the pickaxe is a great piece of hardware for certain applications. And I
yeah,
know that I'm
it
going to
does have
use it.
its limits. Yes.
Yes, it does. But I know that I'm going to use it because there's certain places where the pickaxe is the right hammer or screwdriver, in particular, the right tool for the job. And an Arduino is the right tool a lot. And the beautiful thing about it is these guys have broke this stuff up well, where the pins are numbered on the board. You can see the pin number 3, 4, 5, whatever. All you've got to do is go here, hook the LEDs to the particular pins, and then grab a piece of software and load it. And here's your CVs for DCC. All you do is address it like you would a locomotive, plug it into your program track, address the thing as if you were the latest Broadway Limited locomotive, and you're off to the races.
Yep.
And there's so many channels. Like this guy's built an Arduino controlled uh, turntable. So, and a servo or a turntable controller is a reasonably expensive piece of hardware to get right. And not only this is not just one thing I want to stress is this is not just about cost savings. There's a lot more to it when it comes to flexibility. So, and then I'm going to get into the code, show you a bit of code in a second too. And I know that's going to scare a few people, but I want to preach a couple concepts before we get too deep into what looks like gibberish to most people. You don't have to understand this code. You don't have to know what it says. You can download this. Actually, here's going to be the best way to show this. The most recent MRX magazine that I just showed you a minute ago had a zip file that had all of these projects with it.
Oh, nice.
So it came with servo controllers, crossing bell controllers of multiple kinds, and on their YouTube channel, they had 2 or 3 YouTube videos for a few of these types. And each of these folders just has one file in it, the Arduino file, and that file looks like one of these. And they are like this file this is the control 8 servos with push buttons. So if you want to control 8 turnouts, this is all the code. And you don't have to understand what any of this crap or gibberish, you don't need to understand any of that. All you need to understand is these are the pins that you hook stuff to. And this is even documented in the MRH forum community as to what pin to plug up. Here's where your servos plug up. Here's where your push buttons plug up. That's it. That's all you need to understand about this piece of code. And
That's
all you
really
do,
well documented. It really is.
it's just so simple to understand. It doesn't look like there's as much documentation, but you don't need that much. Here's your push buttons. Here's your servos. Here's your starts. Here's your stops in case you need them to not travel as far as so you can control how far they travel. And this is bonehead simple to make this push button to servos. Now, the accessory decoder that you program as a DCC accessory, you don't even have to look at this code at all.
Yeah.
You just address it and control it in JMRI or with your NCE or Digitrax system. So I have my Arduino plugged up. So that, by the way, this is for the push button thing. This is for the crossing flasher. There's a little bit more to it because this will play back a sound file too, a dig, 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 bell or whatever that tells you, where to put the bell. You put the bell on pin 15.
Now, would you need like a shield board that plays MP3s to make that one work with the sound?
For this one, I don't believe you have to for this one because it's a digital sound. It's a digital, it's a digital bell.
Right.
However, so shields are a pretty interesting bit when it comes to this stuff anyway. There are a tremendous number of shields available. And actually, let me just show you in person. So the board has these pins. These are the pins that we're talking about that are numbered. And there is a upside down. There's a number written on the inside of that pin down through here. Each of those pins. These pins, you can just take a wire and plug it straight in. On my DCC system, that's what I've done. I've plugged a couple of wires, just plug them into the pins. This is what's called a shield. The shield allows you to take things. You can just plug stuff into these pins, run it out to your servos, to your LEDs, etc. Or you can buy shields, and they are designed to align with the pin layout so that they align like a little sandwich. And each of the pins lines up into its corresponding hole. And then on top of the shield, you have those same numbers mirrored, and you can use those same numbers up above. As long as the shield doesn't use those particular pins in its function, you can put another shield on top, and another shield on top, and another shield on top. So you can add up numbers of pins. You could put a MP3 player with an SD card and a speaker on it. And you could put 10 files on it, and you could actuate file 1 at this time, file 2 at this time, and you could loop file 3 for the next 7 hours. And that's like 4 lines of code. And if you don't write code, you can get that off the net and just copy paste the sucker. So this is a motor control shield. And I'm going to show you how this interfaces with a computer, but this is a motor control shield. This is what's used for the DCC++ system. That's also well documented and has some really good YouTube videos by Dave Mondar on how to do it. And it's $7. So all in $12, $14, and you got a full working DCC system. Not only is it a full featured system, but it also has those additional 14 pins for controlling signals or turnouts. And this one has 6 servo connectors on that board.
I have a question here for you, Andy, from Newcastle. It says, what would you use to control control AC trains like O-Gauge and then play sounds like Blue Rail? So I don't know if you could play the Blue Rail type sounds because they're tied to the control of the train. But could you use this to control like an AC?
Recreate the same thing that Blue Rail does. You could take an Arduino, and you could take the Arduino one that's the size of a gum stick and stick it in a locomotive. It has wireless on it, has Bluetooth on it. You could join it with a phone, and you could control your locomotive. That's possible.
Okay.
You're going to have to do a little engineering to make that happen. That's not exactly mainstream in the community yet, whereas the DCC accessory decoders and DCC base station are really alive and well in the community.
Yeah.
But it's possible. But you can do the system where the Arduino controls what a power pack does. It does the job of a DC power pack, of a MRC power pack.
Yeah.
So, because it's a motor control shield, all you're doing is feeding power in, power out. This tells, if you take the jumpers off, the motor control shield has an in, a power feed in, and a power out. This goes to my rails. This gets, in my case, this puts some DCC on it. But if I didn't do this, all it would do is, as I turned the throttle up in software, the voltage would go up on a train. I could run a train with DC with this. So there's no reason you couldn't do that. Put one of these where your power pack goes and control DC trains with an iPhone.
Cal, could you do that with AC trains? Could you run AC power through the motor shield?
Not by default. It's a DC system, but it's not hard to convert from AC to DC.
Right, yeah.
So you could power the system with DC because the Arduino and the motor shield take DC to power it, and then take its output and run it through a tank circuit, through an adapter, and convert it to AC.
Okay.
Power inverter.
Yeah, John.
I want to jump in here just for a second. For those that are not tech savvy like me, you're talking about the shield. That's basically what I would probably refer to as an accessory board.
Yeah, it's an add-on. It's a card.
Add-on. Okay. Dave has got up here MP3 attachments, bunch of question marks. So evidently he wants to play Iron Butterfly on his layout. Then he goes, or MP4s. So he wants to play the Iron Butterfly video while his train is running too. So can you do that?
MP3s are easy. Audio files are easy.
Yeah.
The Arduino has a 16 megahertz processor. The Uno, rather, has a 16 megahertz processor on it. It's been a long time since computers, general purpose computers, were that slow. So they're not well tuned for video. Now, you can strap a small screen on it. You can put a small screen, even a small touch screen on it. You're not exactly going to get Iron Butterfly in 4K out of an Arduino or even HD. If you want to do video, a Raspberry Pi is a better solution for that. That's
or even that. What was
that's
that?
a wholly different piece of electronic hardware. That's a Raspberry Pi with a camera board on it. This is what I built my closed circuit cameras out of.
Yeah.
That's a great topic. We should come back for videos, but audio is trivial.
Yeah, because there are MP3 shields that you can plug right in and load up the sound files on. So,
and if you buy an Arduino with enough storage capacity, the Uno has 64K or something. I can't remember what it is off the top of my head, but it's a relatively small amount of memory to store program code on. So you can't store a lot of an MP3 file on the system. If you bought one with more storage capacity, like the Mega,
right,
or the Dubalave, there's a few Italian words. Okay, so
you know what's funny? I just realized when you said how much storage that has, we have now come full circle to Bill Gates' famous statement: how people will never need more than 64K in their computer.
He did, and back then he wasn't so far from being wrong.
You're right.
But how many people have a terabyte worth of data these days? It's not uncommon.
Easily. I got way more than that.
My monitor is sitting on a box that has 24 ter in it, so 24 terabytes of storage in it. There's there's some free space, but space is a commodity. But when you're talking about these controllers, you don't need the space. The code, that little piece of code that I was showing you to control that crossing flasher, is nowhere near 1K.
Yeah.
There's plenty of room left over. So you could take and hook a speaker directly to the Arduino and store it on there. However, if you want to play decent audio files, good quality audio files, 16-bit CD quality or higher audio files, like I want to for the rivers and stuff that I've been working on, I want a little sound file there nearby. And for those, you get a shield that takes a micro SD card, and there's not one in here. Micro SD card, put the MP3 files on it. They have a speaker attachment or a speaker on board. Run the speaker out. You could control multiple speakers and multiple sound control boards with one Arduino. So you could buy one, put 4 or 5 sound boards on it, and drive it from JMRI so that it played birds chirping in the morning and crickets in the evening. And it would take about that much code to make that happen. And the code's already there. The biggest thing I want to stress in this whole conversation is you don't have to write code, period. You won't have to write code. I built this DCC base station. It does everything an NCE or Digitrax system does, plus a little bit more. And I didn't write or modify or edit or even read one line of code to do it. All I did, so I showed you those lines of code there for the crossing flashers and others. Here's my DCC base station code. The DCC base is this bit of code, and there's a bunch of pieces to this, pages. But all you do is open the file. It's one file. You open that file. When your Arduino is plugged in, and you can attach that Arduino by choosing your board, and it will tell you down here in the corner that Arduino Uno is plugged up on this USB modem port. When you plug it in with USB, it will recognize and see it. Just tell it what kind you have, and then click upload.
Oh, okay.
And in a few seconds, that code will be on the Arduino, and if it just does a job without needing the computer for interaction, like it doesn't need to talk to JMRI, or it talks to JMRI over network or something, then you can unplug it. You're done. Put it up there. Take, 10 seconds, 15 seconds.
Now, Newcastle asked a question here. I mean, you can use JMRI to control these boards. And I don't know how you would, but because there's no particular drivers for them. But if it's DCC control accessory board, then you could, like the one that Jeff Bunce did, the 17 function DCC accessory decoder. That works like any other accessory decoder, so you could hook that into your track feed, and then it would get the command signals like any other accessory decoder.
Yeah, all you do with if you use it as an accessory decoder is you can either plug it onto USB to power it, or plug in the accessory power to control the board, and it will power up to 5 volts any accessory. If you need to control more power than 5 volts, like for DCC system, you need a little more. And then you take a couple of the pins and hook it to your DCC track, to your bus, and you're getting the DCC signal. Plug it into your programming track for a minute and assign it an address, just like any other accessory you bought from Soundtracks, TCS, Lock Sound from ESU, whatever other type of decoder you buy. This is no harder to program. The only extra step is that you spend the 5 seconds to upload a piece of script to it to tell it what you want it to do. But one of the great things is if you decide you don't need it to do that job anymore, you can plug it back into your computer and put a different script on it. It's cross-programmable like the ESU Loc Sound decoders are.
Yeah, it's just like when we did the pickaxe clinic, when I showed everybody uploading the different pieces from Blockley to the chip and then showing how the chip worked. It's really no different than that.
Nope.
Now, what language, for the real techie people out here watching this, what language is this all written in?
So it's kind of its own, but it's really close to being Python. So,
okay.
I write in Python, and I will say that there are some differences or subtleties. If you are a Python guy, there's some subtleties. It's a very lean or very stripped down version of Python. It's plenty capable for the type of processor.
Right.
Because you can use Python and write a video game, but you're never going to write a video game to run on an Arduino, so that stuff's not there.
Yeah.
So, but for controlling pins, turning lights on and off, controlling how bright things are, flashing, making sound, what have you, an Arduino is a perfect tool to do it for dirt cheap. And what's so beautiful is that there's such a community of people like Dave Bondar and others that are sharing this code.
Yeah, I got getting more of the stuff from his site because his pickaxe clinic was fantastic, and that's what introduced me to using that. And he's got some great code examples and stuff up there.
The pickaxe is incredible as a standalone. One, because of cost, that matters. Size is a big consideration, which you can get some smaller Arduinos, but still the pickaxe is incredibly small factor.
Yeah, because the pickaxe is great for I would say dedicated programming. For like controlling fixed items. Like if you want to just simply write a program that'll run a sequence of commands, and then you have one input that you trigger with a push button or whatever, or some other input that starts the sequence. It's perfect for that because you can build a pickaxe board for like $1 worth of components. And,
yes.
Now,
and you're never going to get that cheap, truly, with an Arduino unless you go over the top. And you can build Arduinos from scratch. This is entirely open source hardware.
Yeah.
There's nothing proprietary. There's nothing that you can't learn about it if you want to get that deep. And there's people building Arduinos by just taking the actual core processor. Is that little chip right there? And bending the pins over and soldering a couple resistors to the back side. And they have a controller that's the size of that chip.
Yeah, like you said, that's the size of a pack of gum.
Yeah, it's small. So you can do those things, but if you just buy it on the board where it already has the USB interfaces, the power interfaces, the reset button, there's LEDs on here for testing, and like when it's plugged up as my DCC system, There's lights, indicating power and connection status, etc. And then when you use it as a DCC system, I had to hook 2 wires to jump 2 pins over, which puts DCC signal in the path of my track power coming from my. I have a power supply going out to track power out the white wires. This puts DCC signal into that, basically.
Right.
And then I uploaded that code, took 10 or 15 seconds. JMRI has direct support for it. So you just go to JMRI and tell it what input it's on. If you look at Arduino in the bottom right-hand corner, it'll tell you it's on USB modem 1141, etc.
Right.
Go look down there, go to JMRI, tell it the same thing. Literally, I was up and running in 15 minutes. And I didn't look at the code. I just put it on there.
Yeah, I mean, that's really nice. Now, realistically, you could take something like the Mega and program like a system that will control all the outputs, and then you could take those outputs and trigger the input of, say, a pickaxe chip and build a little pickaxe program that has I want to turn this lamp on for so many seconds, this one, and then do a little lighting program that would turn on your bedroom light in the morning, sort of like Modeler Man Mike's light kit. And then that way with the Mega, you have 54 outputs that you can control the lighting for 54 boards. And
a lot of these outputs are not just they're not just simple on-offs. It has a series of analogs. It has a series of digitals. It has a series of pins that support PWM, pulse width modulation, which is what dims an LED. It's what passes DCC signal. Your DCC signal, we like to argue whether it's DC or AC, it's really neither. It's pulse width modulation. You're sitting a DCC square wave. It's not AC, but it's surely not DC high.
Well, it's really a square wave AC switch at 8 kilohertz.
Yeah, and I've argued back and forth which way it's closer to being, and it depends on what attribute of it you're talking about, whether it's closer to DC or closer to AC. When it comes to power, it's closer to being DC. When it comes to how the signal travels,
that's how they allow you to run DC trains on a Digitrack system, because they use the pulse width to control, in theory, the voltage. Even though it's still got 14 volts, but when you dial up address 0, what it does when you're idling, it puts the pulse width down to near 0.
Yeah, it pulses less frequently.
Right, so that what happens to make the train go faster, by pulsing more frequently, it makes it look to the DC motor like the voltage is going up, when it's really not. It's just getting voltage for a longer period.
Because the motor smooths that out for you, like the human eye. So an LED is a digital thing. It's either on or off. That's it. However, the human eye can be confused quite easily. If you've ever seen a magic trick, you were confused.
Right.
Somebody took advantage of your human eye.
These little Christmas lights here, if they were flashing fast enough, they would look like they were on.
That's it.
But they're not. They're flashing slower, so you see them flashing.
Yep.
So this.
So like the Woodland Scenics little controller, that's so interesting of a piece of hardware for $15, because that's dirt cheap for what it is.
Yeah.
That's not a dimmer. It's pulse width modulation. It's as you turn that thing down, and as the LED gets less bright, as it dims, instead of it sending less than the 1.5 or 3 volts out, it's still sending the same voltage. It's just pulsing that 3 volts on and off slower and slower as you turn the knob down.
Yeah, it's basically it's off more than it's on.
Yep. But it's so fast. We're talking about cycles. It's doing this numerous times per second.
Yeah, well, like
I
said,
the eye smooths that out.
Like the DCC signal is 8,000 times a second. So
yeah,
we got one over here. Art Morgan said, "Good evening, gents. I may be dense. I doubt that, Art. But when you connect the power supply, how is the amps controlled? Don't even know if that's the right question or not."
It's a completely valid question, and it's something that the crazy thing is, model railroading is a fairly electrically intense hobby, but a lot of us don't want to learn a whole lot of electronics, and that's just fine because I do electrical for a living. But when I come home, I want to put static graphs down, so you don't have to learn all these intricacies. All this stuff's been figured out for you. However, having a good working knowledge is a good thing. So amps and volts work exactly opposite. Exactly. And that's why old man Watts come up with the great formula for attributing those together to give us wattages. That is a combination, or there's a mathematical equation, a really simple mathematical equation for volts times amps to get watts.
Yep, that's your power rating.
That's right. And because that's a combination. So here's the trick, and this is a good thing to put in the back of anybody's mind. If you've ever got to get in your breaker box, or if you ever are going to taste somebody, keep these things in mind, how electricity works. Two very simple concepts that you understand even if you're not electrically savvy at all. Volts is the speed at which electrons travel, how fast they can go down that wire. That is essentially it's the simplest way. And if you compare it to water, it's if you put a little rubber ducky in the river, how fast does that little sucker make it? Amps is how wide is the stream, how much water is there. So if you take a wire and you take a cross section of that wire, how many electrons are in that wire at a given time? That's an overly simple explanation, but it covers our bases.
Yeah.
Now here's where the real value of this is. Volts are driven. You put them in. So if you send a car down the road at some speed, you're sitting it down the road at that speed, it's going there. Whereas amps on the other way are pulled. If they don't have anywhere to go, they can't go anywhere. So you could put 100 amps on your track. You're not going to hurt anything until you throw a quarter on the rails. When you do that,
you're burn the house down.
Stuff together.
Yeah.
Because when you put a quarter on there, you're going to pull all of that 100 amps immediately. So having more amps than necessary is only dangerous from a risk perspective and from a potential ground perspective. It's not dangerous. It can't hurt your locomotives. But if you hook 220 to the rail, you're going to see some smoking locomotives.
Yeah.
And not with the smoking fluid. So
yeah, amps are basically whatever device you're using that's powered by the voltage. That device will draw the amps or the current as it needs it. But the voltage you supply to the device.
Yeah, and it has to do with what you're doing is saying that here's my output, and it's a 12-volt output. What you're saying is that output is capable of delivering 12 volts as a speed. That's how fast it can put electrons on the wire.
Right.
Amps is how many amps that thing can take coming through it, that you can pull through it before it'll fry. Basically, how much it's built to take.
Like you said about the water, if you look at size of wire compared to the size of a pipe, I can have 20 pounds of water pressure. If I have a bigger pipe, it's going to flow slower, but it's going to have more quantity. So the bigger the pipe, the smaller the pipe is the amount of voltage. The amount of water coming out is your current flow.
And amps do the work. You have all the volts in the world. I mean, a taser has 10,000 volts on it, but it has next to no amps. It has 100 milliamps or less, so it doesn't do that much damage.
No.
Don't get me wrong. If you tased me, I would cry and pee myself. But it doesn't have the amp. There's not many amps there. Amps are what do the work. When your locomotives are running around around the track, amps are doing that work. And the volts are just how they got there.
Now, this is what Bill Van Linton just commented. Voltage doesn't kill, amps do. And he's quite correct.
Yep.
But at the same time, one thing I've learned over the years in electrical safety class, and I'm sure Bill knows this too, that 24 volts is where your muscles will seize. So if you grab, say, a microphone on a radio handset, you grab it and it's got 24 volts on it, your muscles will seize. And then the more current you draw is what will kill you. The 24 volts won't kill you. But if you have that thing hooked up to a 30 amp power supply, it's going to kill you. But if it's like a 250 milliamp supply, you're just going to get a tingle. It's going to sting. So he's right. Amps will kill you.
Well, that's why 110 volts is often more dangerous than 220, because 220 will oftentimes throw you off of it. Don't try this.
Oh, it will. It will. Trust me, it will.
It does. It hurts.
I touched an open flyback transformer TV that was 250 volts. It kicked me across the room on top of a washing machine. So,
Feel it for a little while too.
oh yeah, man, your arm goes like a dead piece of meat.
Yeah. But when it comes
he
to our
thought it was a
chains,
transformer. That was his wife that did that.
Yeah.
Also, I know y'all talked earlier in the show about the Arduino controlling the turntable. Eugene
Yes.
CG just asked about that. Could you refer back to that article, Andy?
Yeah,
Sure.
that was in this month's MRH magazine.
Well, I found this one on MRH forums. Is one of the man. There's so much stuff on here.
Oh yeah.
There's so much, but if you just go to MRH's forums, mrhmag.com, go log in or not, go to the forums over here, other discussion forums, and just search for Arduino. And actually, I didn't intend to show this one today, but when I got here, it was one of the top hits for recent blog posts or recent activity. And they were talking about this. I was going to show the accessory decoder, but this, for this DCC, and there's the code.
Yeah, that's for
So
the turntable you showed, right? Yeah, because
Yeah.
that one they did. I don't remember who did it, but the posting was about using a servo to drive the turntable via Arduino. But
yeah,
Eugene is asking about a stepper motor, which you'd need a stepper motor driver, right, to do that. Could you?
yeah, you would need a motor control shield.
Yeah.
Which that's what I use for my DCC base station here. So they're $5 or $6. They're not hard to deal with, and there's a lot of code out there for that too. I Again, some of this stuff is not as technical as opinionated. How you like this argument about whether DCC is AC or DC? There's some opinion in how to interpret that. A stepper motor and a servo are pretty close together. I
Yeah,
won't
they
go
are.
so far as to get the hate mail of saying they're the same thing, but they're really close.
They're very close. The stepper motor is driven in a similar manner with pulse width control, but the motor driver circuitry is done differently. It's not done by a digits. I think it's done because usually they're bigger, so there's usually high power transistors involved in driving a stepper motor.
And stronger and have more range,
Yes.
potentially stronger. I mean, they have stepper motors that are big as a car engine. And for people who don't realize the difference in this, a regular electric motor, is you put power to it and it spins.
Yeah.
Where it stops, nobody knows. It's the wheel of fortune. Okay,
Yeah.
$500 trip to Hawaii or whatever's on the wheel. You don't know. With a stepper motor, when you put 4 volts to the stepper motor, when the motor shaft is sticking right here at this exact position, and you put 4 volts to it for 1.74 seconds, it's going to turn exactly this far every time, day in, day out. That's the difference in stepper motor to regular motor.
Yeah.
Now, servo is very similar, except that it just does this.
Yeah. Now here,
a stepper motor is probably better for a turntable.
The brakeman here said, "This whole show makes me want to get back to wiring less and less." I can totally understand that because, like Andy said, sometimes he just wants to come in and play with static grass. I'm the same way. Sometimes I want to go and play with wood. But I don't mind. I love doing electronics and wiring, just like Andy does. So it's just like you take your time at each of them. Don't overdo any of them.
One step at a time.
Exactly.
Take a part of it and approach a part of it. Build an accessory decoder. It's even if you're not tech savvy, if you could follow instructions, and if you could build a decent kit, you could follow instructions. Follow the basic instructions. Build an accessory decoder in an hour, couple hours, and get your feet wet with it and see if it's for you. It's not for everybody, but it's not near as hard as going in you would think. But like I have said numerous times, in everything in life, auto railroading is no different. You're going to pay with one of two things. You're going to pay with money or time. So you can either buy this stuff for $100 or whatever to do some of this, or you can spend a little time. And I quoted an NCE system for my layout. I was looking about $1,200 for 5 throttles, wireless, etc. That costs $13. I need a few iPods too. but $13. And
Yeah.
I haven't found anything it doesn't do for
Yeah.
me.
Yeah,
I
you're
would.
right. And if you're using Y throttle,
Yeah,
now
and I like it better.
you can, yeah, I like Y throttle through JMRI. And here's the thing. You buy $50 7-inch Android tablets. Now this year I've seen them for $40. And you load Engine Driver.
$39 right now on Amazon.
Yep. So that is cheaper than any throttle. It's cheaper by 30% than a Digitrex UT4 basic throttle.
Yeah, the wired throttle. It's a wireless 7-inch tablet that you can watch. What was it, Iron Maiden, Johnny? What were you trying to watch earlier? So you could watch Iron Maiden on your tablet, picture in picture, while you're, running your locomotive for a $40 tablet and $15 base.
And honestly, I like Engine Driver better than Y throttle after I got to use it.
Better.
Because especially if you go down my rabbit hole and do CTC control panels and stuff, the web panels actually work on there. And the Y throttle, I always have issues with disconnecting from the locomotive when I switch to the web panel. So I prefer Engine Driver.
I know it's so difficult to get it to where you could drop out of the app. The only way that this works well on and I'm an Apple guy through and through. Okay.
Yeah.
So this hurts me at some levels saying this, but Engine Driver is a better piece of software today, right now, if you want to run the web panels. However, with an iPad, you could do side-by-side apps. So you can put the throttle over here and bring up the web panel here. That works pretty good. Although
that's only on the newer iPads, though, right? That's not on the older iPads.
I got an iPad Mini too. It works on. It didn't work on the first gen Mini. It didn't work. I'm not sure. I've looked for a reason to buy a new iPad Mini and just haven't found a reason. I've got mine's a couple years old and it's
I'm still kicking every day on my iPad too. So
I bought them every year for a while. I mean, I'm a real Apple zealot. I love this.
I know you are.
Every year for a while, and I haven't found a reason to buy one.
You're a true fanboy, my friend.
AJ has got one up here. A comment: would new technology forever making old tech obsolete? How future upgradable are the Arduinos? What is their design lifespan?
Good question.
That's such a great question, and a lot of people say that. If you ever hear a politician say that's a great question, he's trying to figure out how to lie to you. They're taught to do that. Actually, in school, I have been. But I'm not trying to lie to you. A politician would also say that. They're so flexible because of a couple things. One, they've been around for 7 to 8-ish years, something like that, and it's the same base design. There's no reason to enhance it. You're not going to see Arduinos come out with gigahertz Intel Core i5. They don't need that.
No, there's whole other products for that.
That's right. But it's still the same base design. It's still an Atmel blah, blah, blah chipset. Same thing. It's going to do the same job for years to come. And this thing, for the most part, I buy laptops when I'm ready to buy a new laptop, but before it dies. That's exactly opposite with this. This is something that I will upgrade when it dies because I can't imagine why I would unless I wanted more inputs. And like Barry was suggesting, you could tie numerous together. I'm going to put one in each module, each section of my layout, and just run a telephone wire between them.
Okay, is there
MRL Trains agrees 100% with Barry on Engine Driver. I don't know why he would do that. Also, Chris, could you let me know if you got my email, please?
When you can buy those prepaid Android phones at Walmart for like $30 and just don't put service on them, use the Wi-Fi.
Yep. Like I said, I've been collecting the 7-inch tablets, and because I figure eventually I'll use them on my own layout, because also what you can do is use Engine Driver and just bring, or even go to the web page for the JMRI web server and put them, instead of a push button control panel, put them in a little bracket in your fascia. Now you got a virtual control panel right from the JMRI web server. So you have a touchscreen control with a $40 tablet.
And there's a lot of people doing that, and I'd like to at some point come back and do a Raspberry Pi with the Raspberry Pi touchscreen, as a hangout. The Raspberry Pi touchscreen, it's like $27, and you could have a Raspberry Pi, that touchscreen interface mounted into your fascia. no batteries, none of that stuff that comes with heat problems that comes with a tablet, but you have that, fairly large touchscreen in your fascia for a controller as a pedal. However, to finish up the discussion about the engine driver versus Y throttle, if you're just driving trains, I think Y throttle is better. If you want to control all the other accessories and stuff, I think engine driver's got it. But there's a bunch of people in the JMRI community that are redeveloping a front end that is our Android and iPhone, iOS, iPad, etc., and Windows Phone. There's also a Windows Phone app, by the way, for it right now. But they're developing a single front end for JMRI that's the same across all three platforms.
Oh, that's cool. I just wish the guy that wrote Engine Driver would port it to iOS. But I mean, I will agree with you that for controlling trains, the simplicity of the Y throttle interface it's hard to beat that.
And it's more responsive. I've tried Engine Driver. It's a good product. And its pedal access, pedal interface, and accessory control is better. There's no argument. But for just controlling trains, for doing the job of an engineer, Y throttle is more responsive.
Yeah, I kind of agree with you there. But since I use a lot of, it might shows I use a lot of CTC panels, I just have settled on using, Engine Driver.
Sure. But we're arguing these little fine details. They're both but they're both so good that all we can do is argue these little fine details because they're both completely adequate as a throttle.
Mm-hmm.
However, go look at Dave. Everybody's watching. Go look at Dave Bondar's YouTube channel. He has built a physical handheld throttle with a knob on it that's wireless to talk to this DCC system.
Yeah.
And it's Arduino, and the code's out there. It's wireless, runs on a battery pack, and it's a night's work.
Yeah. So there's even people that have used Arduinos to hook up to a full-size locomotive control stand replica and then tie that into JMRI. So when I advance the throttle notches, it sends predetermined command signals to JMRI to boost the throttle speed of the train on the tracks.
Bruce Kingsley, he's another one you've got to follow. He scratch built. It's not an F unit's control stand, but he actually scratch built one off from the dimensions and size of an F7, I think, or an F9's control stand, and it is has Arduinos in it, and he pulls the brake, sets the dynamics, controls the throttle, and it sends signals to JMRI.
Yeah, I know. I'm trying to think. It might be Bob Buckalow. He's the guy that did the Quaker Valley CTC demos for JMRI. He lives out in Pennsylvania near where Mike used to live at. And I forget whether I think it's him. He actually has built a control stand and everything and the front piece of a cab of an SD45 in his garage. He has a giant projection screen in front of his garage door, and he projects a camera from his train onto it. And then what he does is he has virtual signaling built in JMRI. So like he has a photograph of a control point where he has an actual model of the bridge, and then he puts the virtual signal icons on the photograph in the JMRI panel, and then he can flash them up on the screen and control them right from the cab of his locomotive, and his layout's upstairs, and he's in the cab in the garage.
And I have to have the virtual. We really should do a show just on the virtual signals. They're incredible.
Yeah.
And they're the way that I'm going to get around. I want people to be able to operate trains over the internet on my layout, like I've talked about.
Yeah.
I'm going to use the web throttle for it, and I'm building these cameras off of Raspberry Pi units with the 8 megapixel camera modules. So you get an overall view of your train's location. But you also have the virtual signal, so you don't have to try to read the signal, from a camera view.
Absolutely.
So that's going to be that would be a good show for us, because virtual signal would also let people get their feet wet, test their signal system design out long before they instituted it. So if you're interested in the signaling stuff with JMRI, look into the virtual signals, because that stuff's fascinating.
Yeah, he's actually Bob Buckalow has a lot of stuff on his website about that, because he did the whole CTC panel thing and Panel Pro tutorials for JMRI, so that's definitely something to look at.
And Model Railroad Hobbyist did a YouTube video on the virtual signals. Not exactly how to do them, but how
Right.
they work so you can see it. But the great thing is if you'll lay your layout out in JMRI, go through, get the basic panel stuff done, like we've already talked about in some of last year's presentations. Take what information you know about the signaling that's already been covered until we get back to more of it, and put those in there and put them on the virtual signals and see how they function.
Yeah.
Then you'll know how many outputs do you need on an Arduino. Do you need a 14 output Arduino, or should you buy the 54 output of the Mega to control a set of signals?
Yeah, because there's code out there. There's sketches out there for making a signaling system with Arduino.
Oh, yes.
So that's probably what I'm going to look at for my own railroad, and I'll probably get my hands on code and get some and just play with it and see how it works. So.
Well, I have to say, in my defense about this, I am an electrical engineer by classical training, and I do tech work for a living. But a lot of the reason I got back into the hobby rather, a couple years ago, was because I didn't want to do this stuff. I was not wanting to do the electronics. I wanted to lay static grass, build trees, build structures, do scenery, etc. And it's not my desire to spend all my time doing electronics. So many people say, well, you've got the skill or you love this stuff already. Do you want to spend a lot of time with it? That's exactly not the case at all.
No, you're right.
I can build an Arduino signal system out so doggone quick and leave so much more money available to buy Broadway Limited and Athearn locomotives with that it's just kind of a no-brainer not to do it. And I don't have to get too into the weeds to do it because the code's already on the net.
Yeah.
I got a few comments here, mostly from MRL trains. Engine driver has many options to change settings. After tweaking, can work better than Y throttle.
Okay.
AJ is these full-size controls sound like we are coming full circle back to fixed cab locations.
Yeah.
Barry, this is for you.
Yeah, I see it. I see it.
Yeah.
Trust me, I use milk bones to get them suckers back in the house when they go outside because they want to roam around the yard for 3 hours.
Yeah.
I got to bribe them.
Then also, Chris has got here, Andy, can you walk us through a day one beginner setup of Arduino and software load? Simple LED driver.
Okay. And I promise this won't even take long to do. This is a pretty straightforward process. So Arduino comes in the mail in a static bag. You need a USB A to B cable. B is the printer style, basically. So you bring the board up. Now let me get to a share screen because surely you guys are tired of looking at me at this point anyway. Laugh about it like it's not true. Install Arduino. The IDE software, it's free. It's on the Arduino webpage under something. Download. That's fairly obvious. They don't have a lot on here. It's just this. That's all you need is this. They make it for Linux, Windows, and Macintosh. Like I said, I happen to be an Apple guy, so download it, install it for Apple. Open up the Arduino IDE to begin with. I guess we could open this thing without a sketch on it. Damn, maybe you can't. I'll do. All right. So open it up without a sketch. Let's take that somewhere. All right. So check Arduino without a sketch. That's going to come up by default to create one, but whatever. In your tools, there's a few settings that you might want to set in preferences, but I don't know that I have. I've looked at them, but I don't think there's anything I've changed. Set the board and set what port it's on. Now, it's going to try to detect that if you open the Arduino. This varies by operating system, but generally speaking, if you plug the Arduino in first, it will try to detect what port it's on.
Okay.
If not, there's only a couple on most modern systems anyway, unless you've got a real mess of serial ports. There's only going to be a couple or, if more than one. It's going to detect that USB modem. If you need a driver for it, there is a driver to install, but I don't think on Windows 7 a modern version of Linux or a modern version of Mac OS that you'd have to install it. So choose your port, pick the model of board you've bought, the Arduino Uno or the Mega. There's a reason for considering each of those. That's the Mega, by the way, the 2560. This is the one designed to work with Arduino. So, or the Nano's that little gum stick size one. There. All right. So you've got Arduino. You've got it attached to your actual piece of hardware. You can now take this code that actually does absolutely nothing, and you can upload it to there to make sure that it goes, because Arduino is going to come with nothing on it to begin with anyway. Now, this is where the Arduino, I think, excels above most of the others, is that you can go and get these scripts. So you could get the building lights script. This has a number of pins on it that you can turn on and off to do certain things. But if you want something like, I would try just one of the most, one of the simplest ones they have to begin with, like the blink single, which is going to, you're going to put one LED on one pin. And that's it. Number of times to blink. Your LED pin is pin 12. So take an LED, plug it into pin 12. If you have a 1.5 volt LED, if you buy the LEDs that already have the resistors on them, then you can just plug them directly in. There's a ground pin available on the Arduino as well. So plug the positive side or anode side of the LED into pin 12. Take the ground and pin it to one of the available ground plugs that are on the opposite side of the board, and upload this script to it. And that LED is going to sit there and blink. That's it. Plug the LED into 2 pins, click upload to this, and it's just going to sit there and blink.
That's almost as easy as doing a pickaxe, but making your own code is the harder part. But it's got more features.
It doesn't have a block code. But that there is an argument back and forth for a couple of different perspectives on this. I can agree with that. However, the reason pickaxe has a particular place. Don't discount that board. I think it's exceptional.
It's definitely both have their place.
Yes, absolutely. If it's standalone, doing something entirely unique that you totally will have to custom build code for, and you are not interested in writing any of that code, a pickaxe is an absolute better solution. There's no question. However, for so many things, for literally hundreds of things you would want to do, you will not have to write any code. If you want crossing flashers, if you want to light 10 lights in a building, if you want to do a thunderstorm, they've got the thunderstorm code set for putting some LED strips up and generating the thunder lightning flashes and effects. That code's already wrote. All you have to do is double click, open, click upload, plug the LEDs into the couple pins that are specified, and you have a thunder and light system, and you have $15 in the whole thing.
Mm-hmm. Well, here's someone, if you have links to any of these resources that you can get to either Johnny or myself, we can go and put them into the show notes on the YouTube channel so that, people can know where to go to look for some of these sketches. And just remember, everybody, the sketch is what a pre-written block of code is called. So
in Arduino speak.
Yeah, in Arduino speak. Yes, you would load the sketch into the Arduino software, then upload it or modify it and upload it either way to your Arduino, and then plug the wires into your lights or whatever and go, Yeah,
there's so much information on Arduinos, but what I'll do is get you guys the basic information on Arduino, the MRH references for it, a couple of YouTube channels that are just exceptional for how to get started on it. And I'm on Hangouts occasionally, and I've already done some other things with Arduinos, like the one that runs my doorbell and some of that stuff.
So if you have any links to libraries or railroad related sketches, if you can send them out, and then we'll put them into the show notes, so that way everybody who's been sitting, because we've been nice and steady all night with people watching, so I think everybody was waiting to hear about this, so I'm glad they all stuck around and watched. So
well, there's been a lot of talk in the community about wanting to do some of these things, and some of these things you could spend 50, 100, couple $100 and buy, like the Thunder Lightning system for Broadway.
Mm-hmm.
Some of these things, but of the 100 things that you can do, there's only a few of these things that you could spend $200 or $300 to do. Some of these things, if you didn't build it, you wouldn't have it.
Exactly. All right, gentlemen. I think we gave that one some pretty good coverage tonight. Like I said, we'll try and get all the resources from Andy and get this put together so that you guys can all go and look it up and give it a try for yourself. It's somewhere buried in the deep dark chasm that's my train room right now. I do have an Arduino Mini that I'd like to turn into one of Jeffrey Bunz's 17 function DCC decoders just to play around with it. So we'll see what happens with that. So next year's coming up. We'll be making some announcements soon about what's coming up in the Hangouts and the live show for next year. So everybody stay tuned. I want to thank Andy and Johnny for coming along tonight, and Andy for all the hard work he put in with this. To our viewers, very Merry Christmas and a Happy New Year.
Good night, Barry.
I will see you all on Saturday night for the live show. Everybody, take care.
All right, bye.
Bye.